Nice. Hello. Good afternoon. Yeah, I hope you guys have a wonderful event. First of all, a good round of applause for Your Dreaming, guys. They're doing really good, man. And the organization, the T-shirt colors, yeah. So yeah, welcome. So my workshop is Behind Every Device is a Customer. So it's basically, I will show you how to connect IoT devices to Salesforce. And by the end of this, it's not just that you will be able to connect it to Salesforce, you can connect it to probably any web app. So, so it's not just like it's Salesforce specific. There were some setup things. Has anybody done the setup already? That would speed up the process? No? So, oh, nice. Well, one person, thank you. So, yeah, so you need to, let's start with the setup because the setup requires some time. So please go to yd19.herokuapp.com. Yeah, so if you go over there, please go to yd19.herokuapp.com. The first thing I want you guys to do is you need to download the Arduino IDE. Yeah, so that was a requirement for this. I hope you got this. The Wi-Fi is good, but I hope everything works. So you need to download the Arduino IDE. That's like the most important stuff, because otherwise you cannot connect. And the second one would be you need to just go and click to deploy to Heroku, because we need a Heroku supporting app for this to work properly. So, madam, you need a, wait, I'll give it to you. Bitte. So, Arduino IDE? Yeah, no, maybe? So I'll give 20 minutes for prep. We are here till 4:50. I'll give 20 minutes for prep, those who have not prepped. Otherwise, I'll do a work through. You can go to this website. There is step by step. I have done it baby secure, as it called it, baby proof. So what we are going to do 3 exercises today. The first is going to be Hello World Blink onboard LED. So we're just going to test if the onboard LED is working or not on our laptop, or we can connect it to our system. It's like a very basic thing. The second one is that we want to blink the LED on the board via Salesforce. So let's say something happens in Salesforce, we want to trigger that, and that should blink. And the third one is like the most interesting or complicated also, as you can see, is like when something happens. So let's say this IoT module, what you have, let's say it's a machine, it's an asset, it can be a customer's printer. So let's say if something happens on this, a case should be created inside Salesforce. Yeah, so that's like the end goal. And everything builds on top of one on the other. So, so all of you, are people downloading Arduino IDE? Is it working? Or I can also just go ahead and show it to you guys if you want to. But would be fun if we can play around with it, So by the time, and click the deploy to Heroku button on the parallel side and just log into your Heroku account. I hope everybody has Heroku, right? Yeah, go ahead.
Do you have to use Slack?
I can paste it on Slack. Sure. So I'm in the IoT workshop channel, and I just pasted there. And I pasted in the morning too, and yesterday as well. So yeah. Meanwhile, so we still have some minutes. I'll just quickly do an introduction. So I'm from Berlin. Do I need to put it big? Yeah. So I'm from Berlin. I work as a Salesforce freelancer. I specialize in Service Cloud. I work as a contractor, do end-to-end integration. So I work with clients in getting like their business requirements up to release, documentation, admin, developer, everything. I'm also involved in a bunch of other communities like IoT, DIY, Node.js, blockchain. I work with various Fortune 500 companies and now with startups. And I also co-lead the Berlin Developer User Group. I used to lead the Hamburg group, but now Salesforce kind of prohibited it. So yeah. These are our exercises for today, as I mentioned. Let's see how far we go with that. These are the requirements. Everybody has a developer org. Mindestens sag me, just say, yeah, everyone has a dev org, right? Which you can play around with. Okay, fair enough. I'll just give a quick introduction to Salesforce IoT. It's made up of 5 parts, let's say, more or less. Everybody's familiar with platform events? What are platform events? So platform events are basically follow the pub-sub model, you know, and it's used to kind of trigger, and it's coming from MQTT, which is basically what is used on ESP modules, which is basically you can subscribe to a topic or you can publish to a topic or, you know, vice versa. So platform events are very important for the IoT because you kind of subscribe to any event that is happening on the chip, and then if that event happens, the thing is kind of triggered. Then there are assets. Again, assets can be your it can be your own machinery. So let's say, you know, if you're a big manufacturing company and you have machines which are like $500,000, then these are like your machinery. So you want to know what is happening on them. It can be as small as this. It can be a customer's printer, washing machine, dishwasher. You know, the world is your oyster. Context. Context is what binds the platform event and the asset together. So there are many events which are firing, and then you have different assets. So context brings them together, and context tells you, okay, which platform event is for which asset. Then is orchestration. Orchestration is basically adding the business logic to context. So if this and this happen, what should I do now? What should happen? Should a case be created? Should an email be sent? Should a notification be raised? And last but not the least, you need connected apps. So basically, you need a connected app in order to make the REST calls to the chip. So downloads. Yeah.
I installed Arduino.
Mm-hmm.
So what's next? Should we deploy to Heroku?
Yeah, please do the deploy to Heroku on the parallel. And you have a Mac, so you also need extra drivers. If you go to the app, there is, you need these extra drivers to run it, especially for Mac. So if you go to download, you need these extra drivers, which are not there. And just do the deploy to Heroku too. So, by the way, this app is online, and if you do deploy to Heroku, you get a copy of exact this app. So everybody gets this web app, you know, and then you can take it home and play around with it. You can tweet me out on the Twitter. I've put in the steps as simple as possible. You need to just copy paste it. Yeah. So, because we are in the IoT, I'll do this slide, and then I can start with the sorry. So you all have a ESP32 module. So it's a system on a chip. What is a system on a chip? It's basically, it has all the things, or more or less everything that a PC has. Yeah. So if you would look around it, there's a processor, there are resistors, it has a data, it's 512 kilobytes. So it's not like, you know, our big phones, but it has enough so that you can put code on it, you can put libraries on it, and you can execute it. It has all, there are touch sensors on it, there are different kinds of stuff on it. So it's basically, it's called a system on a chip, and that's like the IoT module. It's kind of, it's $3 if you order from China, but takes long, or you can get it for $10 around any place. And you can possibly do all kinds of experiments on that. Yeah, all kinds of. You already had it, so can you connect the chip to I didn't have to draw the system. Okay, no worries. Okay, so then in order to work with these chips, you need to have the Arduino IDE installed. Everybody has heard of Arduino, right? Arduino? No? Okay. So Arduino is kind of like these maker things. There's a bunch of Italians, they just got together and they're like, okay, we need something. So they got inspired by the Raspberry Pi movement, and they kind of went and they said, we need small chips so that people can program and learn hardware stuff, you know? And they just made these small chips with smaller specs. So it's like they just shrink down a computer into a small chip, and now you can do whatever you want to with it, let's say. So this is Arduino IDE. There's not much to do about it. Let's just open a new. Arduino programs are called sketches. So it's basically a sketch that you have, and I will just open my sketch, the one that you guys have. So here you are. So this is basically a normal, this is a basic sketch. And what it does is, so there is, as you can see, the pins on your boards have numbers and names. And every pin, every number defines something. So different pins have different values. The number 2 pin is basically a pin which you can connect by D2. So it's D2, it's on, if you hold it like this, it's here, and it says D2. So this is the pin, which is also connected to an inbuilt LED. Now I'll try, I hope you guys can see, and it's not that much power, so you won't get electrocuted. So don't worry about it. And if you do, that's the fun of IoT. I like it sometimes, like, you know. So if you switch it on, this is the red light, which is on, you know, and then there's also an inbuilt LED, just you want to test it, like, you know, it's just one LED, which is connected to the second pin. So what you do over here is, you just go ahead and Arduino is a little bit like C. Anybody programmed with C, C++, old? Yeah. So Arduino programs are like C, and they have 2 parts. They have a setup part, and they have a loop part. Basically, in the setup part of your code, you write like what needs to be done, and the loop then just keeps doing it. So the loop is basically, it's listening if anything is happening on the chip, if something changes, anything happened, and in that case, it goes ahead and triggers stuff. So you set it up. So basically, an LED built-in is like, we just define, okay, built-in, LED pin number 2. Then you say, okay, here, now set it to output mode in order for us to send signals to it. Each pin can be an input or an output, so on or off, you know. So we go ahead and do that, and then now here is a compile and here's a check. And you click on this, and then in order to upload the program, now this is tricky part, it would say in the bottom, it would say, and then you need to press this right button which says boot. So now I need to press the boot button, and now it is loading the program. It's very old school, it'll take some 5 or 10 minutes, and I'll explain you the program until now. Then it says digital write built-in high. So basically now we are sending high voltage to it, which is a on. Then we give it a delay, so now you can see it's blinking. Then we give it a delay of 2000 milliseconds, and then we say off, and then we give again a delay, and then you put it on again. And that's now kind of the loop. And this is like a hello world to the IoT thingy where, and this is also a way to test if your chip is fine or not, because it's made in China. So, so it's mass produced, and so far all of them have worked fine somehow for me. So this is like the basic hello world. If you have, I've also, if you go in the downloads, I've put a link to my GitHub repo where you can go and just download all these sketches. I put all the sketches over there. They are nicely commented, and I think they're pretty self-explanatory. Okay, what can we do next? Anybody playing along, or should I just go ahead and do this? Okay, nice, Oleg. You can copy-paste the code. Go to download from here. Go to download and go to sample code. If you go to YD19 sketches, you are here, and then you can just do LED blink test and copy paste the code here. As good. So now by the time he does that, let's go ahead and prepare the next one. So now we have this chip. There you go.
Do you have a USB?
No, I don't have a USB, man. Sorry.
How do you connect it?
With a USB, you need a 2.0 USB cable. Here.
No, we have
Okay, alles gut. All right. So next, let's say we have a chip, and think of it's as a machine or something, and you want to send signal to it, yeah? So it's like in a factory or something, and you want to send something to it. This is not the ideal case, but let's say you want to go ahead and contact the machine, or just check if it's working or not. So basically now I have a second sketch, and it's called Cloud MQTT. Now in this sketch, we just need to quickly update YD19. And the password is your dreaming exclamation, right? Cool. What you also need to do is you need a okay, so I need to explain it to you, MQTT. MQTT is Message Queue Telemetry Transport Protocol, which is basically the same as our event bus, but it is very lightweight. MQTT was developed by Shell Oil Company because they have like pipelines running all across the sea, and they have chips installed in these pipelines to detect any brokerage. And these chips are just keep sending signals, like lightweight signals, okay, working, 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 working. And if they don't send a signal, so they needed something which is very lightweight and which can just say, I'm working fine or not. And for that, you need MQTT. If you deploy this web app, you will have your own MQTT server. I've configured the code, and it will automatically run an MQTT server for you and give you the details. So we need this MQTT server details in our chip because our chip also needs to connect with it. You can run a web server on this. You can even serve HTTP pages on from this. It's a very powerful thing. So quickly going here, we provided the SSID, we provided the password, and we provided like the values that are needed over here. So these are same as my server. And then we kind of just go ahead and initiate the server, and then we are listening for the event at Hello Amsterdam. So this is the event that we are listening at, yeah? So I'll just go ahead and upload this code on the chip now. Again, compiling. Has anyone played with IoT stuff before? Nope, okay. So now again, I press the boot. Now it's doing it. Again, now you will see not the best strength of the device because sometimes it takes a while to go ahead and register the device to the MQTT server. I can also show you the MQTT server. So say Heroku provides a free MQTT server if you have an like account. And it's up to 5 connections, so it's quite easy. So here's the web app which is running. And if you see, here is my server. And here are the server details. Let's go to log, and we will see if a device connected or not. So 14th of June. So new client connected. No, it's the web app through the MQTT JS. So now I'm going to just press the reset just to run the code again in order to show you guys what is happening. So it's connecting to Wi-Fi, connected. Wow. It's not that fast connected at home. So now it's connected to the MQTT network. Now, just to test it, I just made a small ping button just to see if it's working or not. So let me press the ping. No, it's not. So that happens. It's not surprising. Here. I'll tell. So I'll just do it again. Cool. Yeah. So now the ping is working over here, and as you can see, it will stay on for 4 seconds, and now it will go off. Now I'll go ahead, and this is my developer console. I'll open it. It's a very simple, for those of us who know, it's a very simple, I'm just sending, so the web app is working as a mediator between the chip and any other party, because you need a mediator. You need an MQTT server which can convert it to REST, right? So you need some kind of web app. So the web app is going ahead and doing that, and I'll quickly show you the web app code. So it's a normal Koa. Anybody? Express, Koa, Express, Node.js? Anybody? Yeah, so it's a normal Koa app, and there's a library called MQTT made for it, which is basically used in it. And what I've done over here is I've just gone ahead and, as you can see, when we will click send, it will send Hello Amsterdam. So it calls Hello Amsterdam. So we are publishing it to it. And what we do is basically we call the web app from Salesforce, and then the web app sends it to this. So now I'm going to click execute, and it executed. Hey. This one didn't work. Okay, I think the connection is broken. So it's disconnected, the client is disconnected, socket error on client, something happened. So we have enough time, so we'll try one more time. I'll do a ping. Yeah, so the ping is working. The ping is doing nothing but calling just the same method that we are trying to call from Salesforce. So, and by the way, if you have to call the web app, you need to register it as a remote device, a remote site. So now I'll click execute again, and now it's working. So basically, you now sent something here, and now, so it's just a 4-second delay. So I'll open the sketch over here for you guys. So I said, so it's, here is the whole setup thing, and in the loop, it's just running client.loop. Basically, there's a library called pub/subclient, and which helps you do it for you. And here is the callback. And if you would see over here, this is your dreaming. So the message arrived. So I'm also sending a text message over there. You know, here is the web app code. So the message is published, and here I'm publishing the message too. And then here you can see in the device, here it's your dreaming. Yeah? Everybody clear until now? Everybody gets what's happening? 9? I'll do a Deutschunterricht for you later. Yeah, personal. So okay, so just give you a recap what is happening over here. We have a web app which is working as a mediator, and we have an MQTT server which is running on Heroku. The server speaks to, so the devices don't speak REST. Yeah, these devices speak MQTT, they have a different protocol, and we need kind of a mediator between them. So the device is hooked up to this web app, and this web app is hooked up to Salesforce, and that's how the whole train works. The Salesforce, I don't know, so the platform events are based totally on MQTT. Like MQTT is the base of platform events, and I think Salesforce never found the use of having MQTT server. So by the way, Salesforce also killed IoT, but I don't know if I should say it on camera. But we'll talk about. So this is the web app which is running, an MQTT server which is running, and basically you can call that you can call like from Salesforce the web app, and the web app calls the MQTT server, and the same will now, which is like the more important task, which is basically now we'll have the chipset, and from the chip we will call the web app, and but I did it, so this is what I did differently. So now in the third example, which is the most hard part of it, I programmed everything on the chip, so the web app has nothing to do with it. And I'll show you the power of the IoT. So I personally love IoT and DIY stuff because I just like to tinker with things. And yeah, so I'll open the last one, which is, it's called Make Posts to Salesforce. Again, I have to do your Good. So now this must look familiar to you guys. How many of you know consumer keys? Yeah, consumer keys, client IDs. So yeah, so basically I've programmed a whole OAuth inside this chip. It's not recommended. If you don't know C programming, you will run into a bunch of issues. And yeah, but because C is, these devices have 512 kilobytes, and that's like going back in the time, and you have to define what every byte of data would do, what every pin would do, what is ones, what is zero. If you have one extra character, the whole thing would break, because it's like you control the whole flow, how everything is going. So what I'm doing over here is I'm connecting to the Wi-Fi, then I'll go ahead and initiate a HTTP client. You can do this on the chip, so it's possible, but it's not made for this, you know. And you'll go ahead and I'll go ahead and call Salesforce. There's something called as a device. Salesforce has something called as a device OAuth flow, which is basically for devices. So how to register a device and then connect it to Salesforce. So we'll go ahead and let me just check one thing. Why is it login here and not OAuth path? Okay, let's give it a try. So then I'm calling test.salesforce.com. Just give me one quick second. Good. If any one of you did the Salesforce IoT Trailhead, then you would have one of these like context and stuff. So now let me quickly show you how the whole context things work like. So basically, you need to go ahead. Just give me 1 second. Okay, here's touch value. Good. So here, let's start with the platform event. So I've created a platform event over here. It's called Flying Fridge event. This is basically from the Trailhead Trail. So I used it so that there's not too much to do. If you did the Trailhead Trail, you would know it. Basically, it just says, is the door open? What's the serial number of the device? And the temperature. So so this is what the platform event will send. And the platform event will send. So imagine this chip is a door, and it is just sending the temperature and the serial number and saying, is the door open or not? Like just a Boolean, so to say. Then what you do is you go ahead and create context, which is before that you need to go ahead and create an asset. So I have a Flying Fridge Mini. And this is my asset. And what I need over here is the serial number, and what I need over here is the max temperature. So just say, okay, why? So we need the serial number because this device will have the same number, so they can identify that they're together. And then there's the maximum high temperature of 50 or whatever you want. You can also set it to 30 or if we want to. Right. And now, Was? But I don't want this. Yeah. Refresh is the equivalent of switch it off and switch it on again, right? So, now I'm going to go show you the context. So if you click a new context over here, just to say, and you do asset, and then you select the fields, and then you select the same. So you basically go ahead and you need to create the field mapping over here. Like how would the asset identify who's coming over here? And basically you just go ahead and match the fields, and then you say next, and then a context would be created, and it would look something like this. So here is a context, and here are 6 the standard fields, and here are different asset fields. From the context, you go ahead and do orchestration. So orchestration now is basically what happens, and these are where the rules. So it says, okay, a Flying Fridge event is coming in. If the temperature is less than max high temperature, then it's a low temperature. So you go ahead and transition into this state. And then what should happen is a Salesforce output action, which basically creates a case called, hello, you're dreaming 2019. And that's the subject. And you can add more fields and you can say, okay, what should be there, description, blah, blah, blah. And you just go ahead and click finish. You go ahead and click save. And you go ahead and click activate. And other thing you can also do is like high state. So if the temperature is more than the max high temperature, you can again do something about it. And then you can also set up different rules if it's between this and this range. But for the sake of this experiment, we are just going to do it like that. And you go ahead and click activate. So this is how IoT works. Yeah. So you have platform events, you have context, and then you have the orchestration, and then you bring the all three together. So here now we're going to go ahead and because I'm doing on the different sandbox, I'm just going to now go ahead and register this. And I have a connected app. So from there, I got the consumer key in order to go ahead and register the device. So in order to register a device, you need to go to this place. And now I'm just going to push this code on the chip now. And before I do, so we don't have a temperature measuring thing over here, but what we do have is a touch sensor. And the touch sensor also depends on how much area is the touch pin covering. And the touch pin by default is D4. D4 is the default touch pin. If you go over here, so here, touch T0. So this is an inbuilt function, and which is basically the D4 pin. And what I'm going to go ahead and do is just go ahead and connect, like you need to connect a female one and a male one, and then you go ahead and pin it to the D4 pin, which is here. And I'll show you guys in a moment how it would work. So now the D4 pin has a touch sensor to it, and now I'm just going to go ahead and upload the code. Questions, anyone, until now? So it's running now. For this one, it's important to open the debugger because you're going to go ahead and, so it will call Salesforce now like a normal OAuth. Sometimes can happen, these are small devices, and when there's too much code, they are like, so it's uploading. So Salesforce has a specific OAuth flow for devices because devices have less memory. So you get a code on the device which you need to go ahead and copy and paste it and then send it to this login place. And we would see, really, now today. You know, like Murphy's Law, when things have to go happen, they would, like every day this would compile. Third time is a charm. And you need to be patient when you're working with these devices because, as you can see, sometimes they drive you to the edge. Okay. Huh? I'll try one more time. And there's a library called Arduino JSON that we're using. Please check out this library if you're working with Arduino. So these chips are not supposed to be working with JSON, but somebody wrote a C library which is kind of gives you an API. So now it worked, thank God. So now we would see, so it's resetting now, connecting to the Wi-Fi. Wow, so now you have the small code. And this is all you require to register your device. Now you're going to go ahead and go here, click connect. I already have a connected app, so it says the device wants to connect. Voila. Now, I gave it 30 seconds time because I didn't know how fast it would take, like I am used to it. So in 30 seconds time now, it would register, and it would start showing us what's happening. Questions? We can take questions. So now, everything registered, everything went fine. Now it is giving us the touch value. What is the touch value over here? Yeah, so if it's less than 30, so now if I'll go over here, open the serial monitor, so I'm just going to now touch this, and so now it is 12, and what you see, anybody sees these IDs? Do you know them? So the touch went to 12, inside it triggered, and it went ahead and made a post call to Salesforce. Now if we go ahead and go to cases, and go to all open cases, hello, you're dreaming 2019. Yeah, that was about it. So yeah, as you can see here, now the device keeps listening to touch value, like you have the code, you have it, everything, you registered it one time, now it would just keep listening. And imagine this is like in a pipeline or something, or I don't know, it can be a customer's printer, the ink value going down, like the classic examples. And as soon as that goes down, you would see over here, it again made a post call. And this is directly from the chip to Salesforce. Yeah. Thank you. Questions? No? Okay, please.
When you have the IoT cloud, it also gives you additional KPI limitations as it goes up.
Yeah.
Toward that limitation, so I can imagine you have like a lot of devices constantly pinging something to Salesforce, you would hit that limit.
Yeah. So I did this. I'm a tinkerer at heart. So I did this project. The question is like the platform event. If you use platform events, you might hit the limits because Salesforce is a multi-tenant architecture, which, as we all know, and if you use platform events just to keep sending these requests, then you might hit the limit of Salesforce, which is valid question. So the thing is, you are only sending the event when something happens, and that is like a critical thing. So let's say, so right now, if you can see, the device is running, you're not sending any event until it is below 50. As soon as it hits 50, then it is critical to you. Then you want to know about it. If you want to escape that, ideally, you would use a MQTT thing over here. You would use an MQTT server, which would be like this web app, which would act, you would need something in the middle which will act that. And here, this is an Express. I like Koa, by the way. Please check out Koa. It's much better than Express. It's a Koa app. And now here, you can assemble stuff. You can do what you want to do, and then make a call to Salesforce. I just did because I just wanted to check if it is possible. I needed something so this I just did to see if it is possible. And it is possible. It was a lot pain because you need to really, and I forgot programming with pointers and arrays and different kinds of stuff. Now we're used to just make a list, put a data table. But this is like 512 kilobytes of space, and that makes it challenging. But so ideal way is not to do this. This is possible. I just wanted to do this for this workshop. But ideally, you would have something running in the middle, and that is going to go ahead and act as the mediator. And then at that app, you can do anything. It's like you can just control however you want to.
Like summarize and then
If you want to, yeah, if you want to, it can send it at the end of the day. Again, it depends, it's critical. Again, if this was an oil pipeline somewhere and it leaks, you need to know in Salesforce immediately. You don't want to wait until the end of the day. Yeah. Sweet. Anyone else? Yo. Yeah. So this YD19 app is is on there, and I don't have to pay for it anymore, but you only get free 5 Heroku apps, so I'm going to let it be, because I keep experimenting a lot. Do MVPs get more? How many free apps do you get now? Okay, so I'll leave it on for at least another month or so, and then you can just do deploy to Heroku, and then you will have a copy of this app, and then there is everything there. You have the requirements, how to set up, and if you go to workshops, so I really tried to do it like Trailhead style, and basically there are also the codes, there is the definition, or you just need to go ahead and do it. And if there is a problem, there's also a place to, you can tweet to me directly and I'll be happy to help. I'm always happy to help for IoT stuff. Yo. Thank you, everyone.